Hello class, today's lesson is on dividing rational expressions.
Let's talk about dividing rational expressions. Since a rational expression is actually a fraction, let's look at an example of dividing a fraction first. A rational expression is a fraction that has a polynomial in its numerator and or denominator. So to divide regular fractions, it's the first fraction times the reciprocal of the second. Two important things to remember. You cannot cancel across a division symbol, and to divide two fractions it's the same as multiplying by the reciprocal of the second. The reciprocal is just a fancy way of saying we flip the second fraction upside down. So now we're ready to cancel out common factors. 9 will go into 9 once, 9 will go into 18 two times. And that's all the common factors we can cancel. So then we multiply numerator times numerator over denominator times denominator, and we get 8 over 27. So let's look at an example of a rational expression. We have negative 6 plus 3x over 5 divided by 4x minus 8 over 25. Applying the definition for division, it's the first expression times the reciprocal of the second. Now, in order to cancel out common factors, we need to factor each numerator and denominator completely. So, when we factor this one, we take out a factor of 3, a GCF of 3, and we're left with negative 2 plus x over 5 times 25 over, when we take out a factor of 4, a GCF of 4, we're left with 4 times x minus 2. Now, remember that this negative 2 plus x is the same as x minus 2. So let's rewrite that. And now we can readily see that we have a common factor of x minus 2 that we can cancel. And we can cancel between the 5 and the 25 a factor of 5. 5 will go into 5 once, 5 will go into 25 5 times. And we're left with 3 times 5 is 15 over 1 times 4 is 4. So your answer is 15/4. This is a good example to see that even though we started out with rational expressions, our quotient was really constant. It was 15/4. On our last problem, let's look at this example. We have x squared minus 1 over 4x plus 4 divided by the rational expression 2x squared minus 4x plus 2 over 8x plus 8. The first thing we want to do is apply the definition for division, which means it's the first rational expression times the reciprocal of the second. And next we want to factor completely. So this x squared minus 1 factors into the difference of two squares, x plus 1 times x minus 1. The 4x plus 4, we can factor out a GCF of 4, and we're left with 4 times x plus 1. Likewise, with the 8x plus 8, we can factor out a GCF of 8, and we're left with 8 times x plus 1. Now, this expression will take a little bit of work. So let's look at this. We have 2x squared minus 4x plus 2. The first thing we want to do is to factor out a GCF of 2, and we're left with x squared minus 2x plus 1. Now we have a trinomial with a leading coefficient of 1, so we're looking for two numbers that when multiplied together give us positive 1, and when added together give us negative 2. Those two numbers are going to be -1, and -1. And we can readily see that because -1 times -1 is 1, -1 plus -1 is -2. So this factors into 2 times x minus 1 times x minus 1. So we write that here. And now we're ready to cancel out common factors. We can cancel out an x plus 1 here and one of the x minus 1's here. So our final answer is x plus 1 over, and there's one more thing we can cancel. Let's look at the coefficients. 2 will go into 2 once, 2 will go into 8 4 times, and we can cancel the 4's. And so we're left with x plus 1 over x minus 1. And this is our final answer.
Remember, in order to learn math, you've got to do math. You got this. Class dismissed.